We're going to do our best to make caching as interesting as possible. That is a sort of a tough task, but we've been doing this talk now for a couple of years. This is our first time at Dev Summit, so hopefully it's well received and we can bring it back again next year. So go ahead and mash that like button at the end of the session, please, on our surveys. And if you didn't, well, it's all Grima's fault. All right. So what are we going to talk about today? So I know this is a bit moot at this point. It's a late Thursday session. There is one key session that I think you should all attend. Just plug in my good friend Whit and Philip's session tomorrow at 8:30 a.m. It's early, I know, but definitely give it a go. Best practices for layers and service types.
And most of these sessions are recorded, so you can go back to look at the proceedings. And before we jump on, I want to introduce myself and my friend over here, Tommy.
I'm so rude. I apologize. I'm sorry.
So I'm Garima. I'm the PE in ArcGIS Enterprise team. I'm a PE for the last 10 years for caching in enterprise. Tommy over here, would you like to do the honors?
So Garima's been my therapist. I'm in professional services, so I call Garima every day and we commiserate on things and she helps me out and we sort things out, and hopefully the sharp pointy objects that I've fallen on, the little Legos buried in the carpet that I've stomped on in the middle of the night, I can save you the pain and anguish of doing that. I have a caching problem. I've been doing it for about the better part of 10 years, so right around the same time that Garima started.
So together we work like this, that he runs into a problem and he tells me the bugs and I try to fix it, and together we try to improve the experience for you.
And hopefully we have. It's been a good relationship so far, so we'll see how we last today. But yes, so our goals for today, we really want to convey a few key points. Now we want everybody to walk away from this understanding the differences between raster tiles and vector tiles. More importantly, what to do with them. How do we share them? How do we publish them? Once we get them published, how do we actually process them, or something that we refer to as cooking, and the best practices associated with that, as well as the various ways and clients that can consume our tiled layers, our cached base maps, our cooked, delicious little delicacies. But to get there is a bit of a convoluted path, and this is what we're going to try to accomplish. We're going to hit the overview and basically just work all the way through to the very end with bouncing around a little bit, but we're going to try to ground each section with a little bit of a summary to kind of recap where we're at. Plenty of room on this side if you want to come on in. Don't be shy.
In the end of all this, we'll be open for all the questions. We have some sort of common questions that have been asked throughout the last few days in Dev Summit. We'll go through that and then we'll open it out to you.
Now, to be fair, this is probably about a 3-day workshop that I usually give with customers, and we've condensed it down to an hour. So buckle in, you're about to get the fire hose. But whatever we don't cover here today, Garima and myself will be on the Explo 4 over at the Enterprise Island, so please come by and talk with us afterwards if we don't have enough time to get your questions. All right, let's jump into it. I think you're up.
So what's the difference between raster tiles? If you are not well versed with what raster tiles are, I'm going to give you a 30-second overview about what raster tiles is. Go for it. Sure. They are pre-rendered snapshots where you take images of your data. You render them and you take it and save it in a JPEG or a PNG format. There's a tiling scheme that is being followed, which whereas you use your projection, their origin, the tile and dimensions are fixed for this tiling scheme. There is an extent that you cook the cache for. This is the coordinate reference system for your tiling system, and you generate caches for each and every level as you go up, all right? It's a regular grid for raster tiles, okay? And that's how you get your generated cache, and whenever users request your data, they get the data from your cache, not actually rendering the data, hence improving the performance of rendering of your map services. So always cache your map services which are being requested highly by the users, and that's how you can improve the performance of those services, by caching it. Enter the world of vector tiles. And
so these are, instead of JPEGs and PNGs, we're actually delivering containers of your data. So geometry and attributes are flying across the internet and landing on your device. Mobile devices, tablets, laptops, workstations. Now, we actually separate the styling information from that tile, so that data and the information that hits your screen is also going to have a component, a sister file, a style file that actually describes how to render the map. So we're actually letting the client device and the browser, tablet, whatever, that's actually responsible for rendering the map. We give it all the instructions that it needs to draw the map on the fly for you.
So the server is not handling you a JPEG or a PNG file, it's handling you two different things. Here's a tile set of the geometry and here's the attribute. Go mash it up on the client side.
Yep.
Server is not responsible for it.
So she mentioned something called a tile set. So because we're not just sending JPEGs and PNGs anymore, we're actually sending you a couple of different things. There are several components to the tile set. Of course, we have the tiles, our little buckets of data and geometry. The styling, the actual rendering instructions for our map. Sprites, these are all of our icons, our fill symbols in a sprite sheet. And they come in two flavors, a standard definition and a high definition. The JavaScript API and the Runtime API, as well as ArcGIS Pro, are smart enough to know when to ask for which based on the resolution of your device. So you don't have to do anything programmatically to say, oh, I need to request the high definition version of this or the standard definition version. So if you have a 4K screen on your laptop, you're going to be looking at the high definition version of that sprite. Now, fonts were a tricky bit, and instead of actually trying to launch true type fonts across the web, fonts are actually encoded as protocol buffers, and there's some very specific things on how this is taking place. But basically what we're saying here is the device that we're sending the tile set to doesn't need to have the font installed that you authored your map with. So I know Arial is rather ubiquitous, but if for whatever reason you chose to use Comic Sans, you could actually launch Comic Sans fonts to any device that you choose. All right, it's actually packaged up in the tile set. Now we do deviate slightly. With the ArcGIS implementation, we have another component called the index. The index is an intelligent polygon that is generated on the fly when we create vector tile packages. It's going to analyze the density of our map, and it's going to basically build out the to-do list when we're actually cooking these tiles. It's going to basically define where our data is most dense and where it warrants caching tiles to a larger level of detail.
So think of it when I said that for raster tiles, it was a regular grid. You're always caching those areas. In vector tiles, it's an indexed grid. Mm-hmm. And that's what the picture out here is showing you. Mm-hmm. There's a density of the grid increases. It's more finer in the city regions where there's more courses in the ocean. Mm-hmm. And that's how you achieve better performance with vector tiles.
It's a good point. This purple grid is actually not part of my map. I didn't want to make it that ugly. This is actually just the index grid. So over downtown San Diego, where we've got those really small squares, each of these squares represents an actual tile, a protocol buffer, an actual tile of data. So we can see over downtown San Diego where perhaps we have building footprints or really dense parcels. We've actually warranted going down to a much larger level of detail. The smaller the square, the larger the level of detail. And there's attributes in that polygon that would indicate what level of detail, what row, and what column that tile is.
So this indexing is done for you by the software. Mm-hmm. You are not responsible for it.
Right.
Okay. So you don't have to define that here, have a coarser grid. It continues to create the caches for you.
So the ArcGIS implementation leverages several open source projects, the first being the vector tile spec from Mapbox. This is hinged on the Google protocol buffer specification. Again, the protocol buffer spec defines the container, the bucket of things that we're going to load with. And then the tile specification describes how we're going to encode a polygon or a point or a line and where attributes get set inside of that bucket. Now there's a third specification, and this describes the syntax for that style file, and we call this the style specification. So when you get these slides later on, these are all hyperlinks to the actual spec page. You can actually review the syntax and see everything that goes into the style file. Now again, one place where we do deviate from the tile specification is this idea of this indexed approach. The interesting thing with vector tiles is that you don't need a tile at that level of detail that you're currently viewing to actually render a map. With raster tiles, when you hit the last tile, that's it. When you zoom past that, your map goes away. With vector tiles, we can zoom past that. Why? Well, we've actually sent all the geometry that you have in your map. It's not like CSI style enhancing the map. We're not going to invent vertices on the fly. Okay? We've got the full fidelity geometry in a tile. already delivered to your device is just going to continue to render and draw that tile and that geometry and those attributes as you zoom in. So in theory, as you zoom in at 1 to 1,000, you could be looking at a tile that was streamed back at 1 to 36,000. Again, seamless to the user, but what this does is actually saves you on time to cook, as well as the overall storage impacts, which I don't want to steal your thunder, so we'll talk about that a little bit later. The other cool thing about vector tiles is, yes, the tiling specification does recommend Web Mercator, but you're not stuck with just that. Any supported coordinate system inside ArcGIS Pro, to include the very, one of my new favorite coordinate systems, yes, I'm a projection geek, is the new Equal Earth coordinate system. We do support that as well. But if you wanted to create a vector tile map in good homolocene, you can do that. So again, I mentioned it briefly before, but the other interesting, because your device is the thing that's doing the rendering, your high definition screen is going to basically drive what is being rendered, okay? We're giving you the geometry, we're giving you the attributes, we're giving you the styling. The GPU on your device, your tablet, your laptop, that's actually going to create an image at device resolution. So no longer do we have to try to tailor a raster tile at 96 DPI. We don't have to try to target a specific DPI for the various devices out there. Vector tiles let you just render the, again, we put the onus on the device to render, and it renders it at the native resolution. So as a result, you get clear, more readable text. And if we fast forward here through the slides, we actually do reorient the text as well. So if you start rotating the map, if you're perhaps doing in-car navigation inside of an app, if you rotate your phone, you're not going to be looking at an upside down text. The labels are actually separate from the base map. They're no longer rasterized into the tiles. Perhaps the most compelling thing with vector tiles is this idea of we can cook one tile set, and because the bucket of data is separate from the styling information, that style file is different, we can modify the style file without having to modify the base tile set. And so we can modify the styling on the fly, which is what you're seeing a little preview here.
And when he's saying style, you can say that geometry should be black or red or transparent. Mm-hmm. That means that you're getting a potential to remove features from your layer, a cached layer, and you can have multiple tile sets from it.
So let's run you through a couple of quick demos here talking about restyling specifically. So there's a few different ways that we can restyle a vector tile layer. The first is by using predefined styles. So in this case, we're actually, I wrote a terrible little web app, so please check it out, make fun of it, and if you can help me out, please do. But this is actually calling pre-configured styles from ArcGIS Online. And so in this case, we're able to mash them up, switch the styles around, and our application is just very quickly able to render those on the fly. Now, you may see some requests for the actual protocol buffers back to the server, but we're leveraging browser cache. We've already sent you the tile, so it's much faster to render once you've already downloaded the information on your device. So that's using a configured base map, but what about restyling on the fly? So you may have seen a couple of demos of this already. But within the JavaScript API, we can actually modify and manipulate the styling of a tile set without having a pre-configured style file. In other words, we can change the color. And so here's an app that my good friend George wrote that is modifying 67,000 flight tracks on the fly in the browser client side. We're no longer making server calls to try and render this image on the fly. All the geometry and attributes have been sent. And in this case, I've actually encoded some additional data, like destination, time zone differences. So not only can we change the coloring, but we can also filter the content in our screen and leverage the data and change the symbology of the line based on, in this case, the time zone difference between London Heathrow and every other origin or destination airport. It's on GitHub, check it out, really good example. Thirdly, I can't count. Something you also may have learned about this week is the new vector tile style editor. A very powerful application that lets you take a hosted tile layer from either your own Basemap that you've authored or from ArcGIS Online and manipulate very quickly and modify, save, and restyle on the fly. Save it to your content, share it with your organization, but also allowing your users, consumers of your map, to go in and make their own renderings of their map. Again, you don't have to create your own base map. If you can get by with using the existing ArcGIS online base maps, go for it. I've seen quite a few rebrandings of this that are both creative and a little harsh on the eyes, but you can do that.
Again, in this app, the tile set stays the same. It's just changing the style.json.
That's a good point, yes.
Okay? We're just modifying the style.json easily for you.
Okay. I think what I like most about this application is it makes it very easy. You pick a style that you want, and just by signing in and then hitting the save button, it's automatically saving that tile layer to your contents. It's very seamless, very easy. There's no jockeying of style files around, using a text editor on your machine to try to craft a base map from scratch. You can use this, much cleaner experience. Really enjoying it. All right, so let's get into the nitty-gritty here.
So let's try to understand how the raster tiles are different from vector tiles. The raster tiles work with MXDs. They come from ArcMap or ArcGIS Pro. Vector tiles, on the other hand, come only from ArcGIS Pro. They are made using map project files. Raster tiles can be created using ArcGIS Desktop or ArcGIS Server or ArcGIS Online, while vector tiles can only be created by Pro. They can be published to ArcGIS Online or ArcGIS Enterprise accounts.
Right.
If you look at the file structure on disk, how would they be different? Raster tiles, you'd have a configuration file, conf.xml, which is a tiling scheme, and the PNG, JPEG, or mixed tile format stored in bundle, which is the compact storage format. In the vector tiles, the tile sets are still being stored in the level folders as bundles. The PBF formats are still inside the bundles. But additionally, you can see these resource files, the fonts, info, sprites, and styles, which are being manipulated by this vector style editor app. All right? So that's how it will be different on the disk.
If you're like me and you like ripping the lid off the black box, this is what you would actually see on your hosting server when you publish the tile layer. So if you browse through the cache directory in your hosting server, this is what you would see. If you do this to ArcGIS Online, you can't get to that.
The point to note here, it's on disk.
Yes.
These are on disk. It's still going to your ArcGIS server cache directory. It's not
the hosting server is cache directory.
Yes.
Yes.
And that's what you need to know when you're working with ArcGIS Enterprise, when you're installing data store. It's not going to your CouchDB.
Right. You need at a minimum, to get a hosting server, you need the relational data store. For vector tiles and raster tiles, you don't need the tile cache data store. Tile cache is specifically for 3D cache, scene layers, scene layer packages.
So, as we said before, raster tiles for the entire world is a regular grid. And for you, those of you who have been working with caching for years, you know that how long a particular raster tile can take. For the entire world, the ArcGIS Online base map images that we create, it takes 20 terabytes of disk space and months or weeks for a cluster of servers to work with.
That's the street map, right?
Yes.
Okay, street map is 20
only
terabytes.
One tile set. You'd have to create multiple tile sets. So if you're in your organization and you want to eliminate the load on your servers, you need to cache, but you'd have to cache multiple tile sets, your imagery, your tile set, your Lancet parcel, your water features, differently.
Light gray, dark gray, canvas maps, hybrids. So each of them would be a separate bucket of raster tiles.
So 7 different maps multiplied by 20 terabytes. That much disk space you would need. Enter vector tiles.
So when we compare that to vector tiles, you no longer need ArcGIS Server. Again, ArcGIS Pro running on your workstation is all you need. The similar base map for street map is going to process in anywhere between 12 and 18 hours. And it's only going to create a tile set that is 40 gigabytes. Again, full fidelity geometry, full zoom scales, worldwide, 40 gigabytes. Compared to 20 terabytes weeks of processing, it's a huge, huge trade-off.
It's a desktop machine creating 20 gigabytes.
Right. And the biggest difference is we're not rendering tiles. We're not letting Maplex fight itself out cross-side, second order, third order placement of labels. We're just converting geometries and attributes and populating them into tiles. So it's a very fast process.
And nobody can come to you saying that the way you have labeled your streets, I don't like the color. Can you please change it to a salmon pink for me?
There you go. Here you go. You can do it. You can change it yourself.
Yes,
And
go
again,
ahead.
multiple styles from the same tile set.
So let's look at the architecture. The ArcGIS platform as a whole supports both vector tiles as well as raster tiles. Traditionally, you've been working with ArcGIS Server and ArcGIS Online. There's this offering of ArcGIS Enterprise, which is just like ArcGIS Online, but it can be on your on-premise hardware. In ArcGIS Enterprise, your ArcGIS server can be federated. And we have something called hosting server, where you install your managed CouchDB or managed data store for storing your feature content. But again, as we mentioned before, the cache content is not going to your CouchDB or the data store. It's going to your ArcGIS server cache directory. But it's called a hosting server for a reason. When you're packaging up your tile content, the vector tiles in ArcGIS Pro, and uploading it and publishing it to your ArcGIS Enterprise, it's getting hosted on this hosting server. And that's why the term hosting server comes up. The raster tiles can be published to ArcGIS Server, the whole entire spectrum, but vector tiles can only be published to ArcGIS Enterprise or ArcGIS Online. You'll have to upgrade your standalone servers to ArcGIS Enterprise to get the benefits of vector tiles. These tiles are called hosted tile layers. Anytime you package the vector tile layer, it's only the tile layer that's getting uploaded to your enterprise. It's not copying your data, your file databases to your hosting tile server. It's just uploading all your vector tile content. And that's why you see copy all data with vector tiles. And when you're publishing from Pro to a standalone ArcGIS server or federated server, it's called cached image layers. And you can still cache them using raster tiles. And it's called cached map image layers. In ArcGIS Server and Enterprise, we additionally have the feature where you can store your caches in cloud stores like Esri or Azure Blob Stores, so you can hold your 20 terabytes of data.
So this is an eye chart. I actually did a lot of research into this. I looked at all the ways that you're not supposed to present tabular data in a PowerPoint presentation, and then I did it. But the good news is that in that read ahead that's out online, don't worry about trying to get a high resolution picture of this. I made a nice PDF for you to download. It's got all these nasty eye charts for you to look at and review for later. So this is just purely for reference. So we're gonna skip ahead, jump into some use cases. So if you're not already drinking the vector tile Kool-Aid, this was a game changer in terms of the kinds of projects that I have to do for customers. No longer am I agonizing over weeks and weeks and potentially hundreds of terabytes of storage cache to manage. I can now take one tile set and basically serve all those unique styles with 22 gigabytes, 40 gigabytes of tile set cache. So I was very inclined to just quickly say, all my vector projects, those automatically become vector tiles, but I would caution against this. As with any organization, you're gonna have some holdouts, folks that are going to cling to ArcMap and prying it out of their cold, dead hands. ArcMap, as of right now, I'm sorry to say, will not be able to render vector tiles. The applications that can display vector tiles are ArcGIS Pro. I know, I'm with you. Here's ArcGIS Pro, JavaScript API, Runtime API. Those are the applications that can consume vector tile layers. So for your organization, if you have desktop users or a large component of desktop users, we still need to care and feed our raster tile projects for your vector maps for that population of users.
And I want to add to it, if suppose you have users using old desktops which do not support WebGL, the advanced web drivers.
That's a good point.
They would not be able to consume vector tiles. Again, it's a client-side rendering, and they have to be knowledgeable to be able to merge the tile set with the styles. And that's why we need this advanced capabilities in newer clients.
Okay. So let's jump into what's new. And actually there's quite a bit, specifically within ArcGIS Pro 2.3 as it pertains to authoring your base maps. Specifically for Pro, and I believe it's coming to the JavaScript API soon, if not already, is this idea that we can have multiple style sources. Who's familiar with the style specification? and sources. Obviously, we got a couple of folks that we're speaking the same language. I've got an example here. I'm not going to dive into it, but essentially what we can have is a street map tile set as one source of tiles, and we can have in our style I don't know, contours. We can have a contours tile set. If we were to mash these two tile sets together and cook them together, who went to my lightning talk, the speed geeking? I see a couple of familiar faces. We're talking about payload analysis, and then when tiles get too big and bad things happen to your web browser. That's basically what you're going to do. You're going to overwhelm that bucket of data, and instead of sending a nice compact thing at your screen like a JPEG, we're going to be streaming MP3 files and Netflix videos, which is just bad. It's going to take a long time, and your browser's just going to run away and cry. So again, there's an example here that we can jump to and actually show you specifically what that is. As of right now, I believe only Pro supports it, but don't hold me to that. We've also improved our labeling support, so the actual rendering of vector tiles, but also how those labels are encoded is improved. We support multiple label classes, specifically from like a points of interest feature class, a point feature class. Translation style abbreviations, so if you actually have an abbreviation dictionary, it'll actually honor that and encode those abbreviation values into the actual tile itself. We can force stacking on it. Unfortunately, once we force the stacking, you can't unstack it in the style because it's actually going to be encoded in the tile in a stacked manner. One of the two big things that I've been lobbying for is label repetition and never remove labels. So if you're in Mapplex and you're flipping switches and turning dials, we're actually having a lot more of those settings carry over to the style automatically. So as opposed to having to do the dirty word that Craig Williams hates when I use is post-processing of our vector tile package. We actually are cooking it. What you see is what you get now. We're getting there. It's not completely there, but again, I'd say it's about 98%. And just so everybody knows, about 75% of the statistics that I make up, I just make them up on the fly. So, you want to talk about this?
In ArcGIS Enterprise and Online, recently we have added ability to cache shared instances. If you want to elevate the resource crunches on your machine, we have introduced something called shared instances. Go ahead and look at the Friday evening session by Witt and Philip on that, where you have multiple map services can be using the same instance, and we can support caching of those instances. We have included a TPKX format, which is an open tile package format. So anybody can create their own tile packages using our open spec. We have also added ability to export vector tile packages and tile packages using polygons. This will be very helpful for collector apps. We also added ability to replace vector tile layers. This is for updating vector tile layers in ArcGIS Online. The UI experience will be coming soon, but it's already there in ArcGIS Enterprise. And additionally, we have this feature where you can auto-update hosted tile layers based on hosted feature services in ArcGIS Online. So anytime you make edits in your hosted feature layers, the tile layer will automatically get updated in ArcGIS Online.
The important piece here is this is ArcGIS On only. So if you got more questions about those workflows, please come talk with us afterwards out on the expo floor.
Now let's jump into the best practices.
Oh boy, all right. Let's take a little stretch because this is where we're going to go really fast. So when we talk about optimizing our maps, really what we're doing is we're actually trying to improve how our map is going to perform for both raster tiles and vector tiles. So by virtue of what I've been doing recently is by virtue of optimizing my maps for vector tile authoring, I'm actually seeing about a 100% improvement in caching of my raster tile projects using the same map. So the same unoptimized map, I guess I'll call it, would take approximately 4 hours. After I've put it through the optimization process to create vector tiles, when I cache that same map as raster tiles, instead of taking 4 hours, it's able to take 2 hours. So there's some goodness happening across the board that mutually benefits both raster tiles and vector tiles. So we kind of lump these together into one section.
And when he's saying the goodness is happening, it's happening in ArcGIS Pro.
Correct. Right. All right, so first up, let's look at our data. Who's using an enterprise geodatabase? All right, stop that. I'm joking. When you're going to generate cache, either raster tiles or vector tiles, export a copy of the data layers to a file geodatabase. Bring the data closer to the ArcGIS server machine. Bring the data closer to your workstation that's doing the vector tile work. I've had instances where folks are using an enterprise geodatabase in a data center across the country, and they were wondering why it was taking 6 hours to process a vector tile base map as opposed to 20 minutes. All right, clean up your data. Eliminate any duplicates. Sometimes with parcel data, we'll have multiple overlapping lots that are not immediately visible to the human eye. But if you've got overlapping geometries, you're cooking that geometry twice. Every record that's in your feature class is going into the tile in some way, shape, or form. So if you've got duplicates, you're bloating the tile. Fix your geometry errors as well. I know if you're using an enterprise geodatabase, we're doing a lot of this fixing on edit and on load. But if you're not using an enterprise geodatabase, again, almost all my workflows right now are file geodatabase driven, so I break a lot of geometries. Cleaning up the geometry errors will allow the encoding of geometries, the conversion of the shape blobs into the actual protocol buffers go much more smoothly. Look at how dense your data is. Who took the cartography MOOC? And no, Ken, I'm not saying it because you're in the audience. There was a section in the cartography MOOC that talked about generalizing the data. There's another offering coming up in April and May. If you're not signed up for it, sign up for it. It's awesome, it's free, enjoy it. The folks that are giving that class are absolutely fantastic. But in there's a great exercise that talks about generalizing data and actually walks through this process of optimizing a map document. But in essence, what you're actually getting ready to do is build a vector tile package at the end of the exercise. And that whole exercise was phenomenal. So if you haven't taken it, sign up for it, do it, and you're gonna learn a lot about generalizing and making smarter decisions about when dense features are displaying, but also leveraging the new tools in ArcGIS Pro for how to control and constrain when features are rendering and drawing. Don't start from scratch. Who's been using Pro for more than a year now? Excellent, excellent. Who's never used Pro before? Excellent, perfect. Don't start from scratch. Pro's got an awesome import feature. Bring your MXD in, it's gonna take all your symbology, your scale dependencies, your Maplex rules, your Maplex priorities, all that stuff translates over so you don't have to rebuild your map from scratch. Start there. Make sure that you establish your scales in your map from the tiling scheme that you're going to be targeting. So if you're creating maps for ArcGIS Online, use the Web Mercator tiling scheme scales and all the scale dependencies that you set, all the pick lists. Don't round the scales, don't pick a little bit above or a little bit below, specifically pick an actual scale. And tied to this is, we've actually changed the scale logic inside Pro to more align with how vector tiles render. In other words, inside ArcMap, if you set the min scale and the max scale for 2 different layers to the same, they'll both display at that scale. Inside Pro now, there's an option to change that behavior so that at the maximum scale, at 144K, layer A stops rendering, and at 144K, layer B starts rendering. This is how vector tile style is really designed to work. And so we actually have changed the authoring experience to more align with that. So what you see in your map is what you're going to see inside of your project.
And when he's saying vector tiles, it's still not applicable only to vector tiles. Raster tiles can have the same benefit.
Good point.
All right. So whatever he's talking about here is beneficial for both workflows.
Limit the number of layers. Again, we can take that same rich cartography that we were cramming into 16 group layers with scale dependencies, with lots of duplicate layers. We can actually achieve the same rich cartographic quality now with a single layer in the table of contents by way of scale-based symbology, scale-based sizing, alternate symbols, forgetting one, display filters, scale-based definition queries, basically. If you want a demo on this, come see me on the expo floor and I can walk you through those 4 features. We just don't have time to cover that here today, I'm sorry. Duplication of content is gonna be your enemy. Layers, geometries, more geometry in the tile than necessary is going to negatively impact that payload. Again, we want to make a nice compact thing flying across the internet, not a big bulky MP3 file. We do have the ability, you saw the little demo before about the flight tracks in London Heathrow. I've added and supplemented some data into the tile set. There are workflows for doing that, but be conservative. Vector tiles really aren't the best mechanism for full feature attribution. So for things like parcel data, we don't necessarily want to put all the tabular information from our parcels into the vector tile. As appealing as that may sound, and when we do eventually support pop-ups in the JavaScript API, that would be appealing. However, again, the more stuff you put in that tile, the bigger, the heavier it gets, the slower it's going to perform, the more likely that you're going to overwhelm the browser and it's going to be unable to render and or crash the browser. Instead, in that scenario, use vector tiles for visualization and have an underlying feature service which has the full featured attribution data that you can use for your pop-ups. Vector tiles for visualization, feature services for pop-ups.
And queries and identify.
Correct. All right, almost there. Again, more of a guideline than a rule. Avoid group layers. And again, this is more driven around how the vector tile style editor interprets your style. The more nested group layers that you have, the more cumbersome the table of contents gets inside the vector tile style editor. 1 or 2 levels deep is fine. Grouping things thematically, hydrography, so you'll have polygons for water bodies and rivers, actual like polylines. Grouping those in one hydrography group layer is not going to offend me. But the important thing you're no longer hiding behind your map service with raster tiles. Everything is laid bare. Your table of contents, your poor naming conventions are all going to show up inside the style. It's going to look at the table of contents and it's going to convert that directly verbatim into the style file. So be kind to the users that are going to be restyling your maps. Take some time, make them nice, neat, concise. Don't make them too verbose, but make them descript enough so that they can stand on their own, so folks know what they're actually interacting with when they're modifying your map. So in summary, there's going to be a thing inside Pro, inside the map settings, uncheck the box. Okay, just if there's one thing you walk away from here, it's because you hear Tommy's voice in the back of your head. He said, uncheck the box. I should uncheck the box. If you see a box, uncheck it. But specifically, the box we're talking about is draw up to and including maximum scale ranges. This is what changes that behavior from how ArcMap draws things to how ArcGIS Pro will now author things when we're doing it from scratch.
So
go ahead.
Let me add, just in ArcGIS, ArcMap, you used to say 1,501. That's
add one and you subtract one. You no longer do that.
Don't have to. Yeah.
And so that actually fits to this next one. Pick a tiling scheme and do that. Well, the very first thing, uncheck the box. The second thing, set your scales. Because every other user interface element for pick lists, scale bars are all going to be derived from that first decision. And if you've got to go back and now modify scale dependencies because we kind of went off the tracks and forgot this step, you're going to be doing a little bit of rework. Again, get your data into a file database, bring that locally to your machine.
And when he's saying locally to your machine, it's either your ArcGIS Pro machine, if you're working with multiple machines, in ArcGIS server sites, copy the file database in each and individual machine that is going to cache for your raster tiles.
Get your data healthy. And then there's 2 sections in our help documentation on authoring a multi-scale map. And they talk specifically about making a valid map using valid symbology, things that will actually cook into a vector tile package. I think the shorter list is what won't cook. So again, I'm sorry, I have to be the bearer of bad news, but annotations will not cook. Representations will not cook. All map effects are not yet supported. Right now, just the move effect is the only supported symbol layer.
And dimensions.
And what?
Dimensions, right.
Oh, and dimensions too also will not cook. And then make an efficient map. Apply the best practices of scale-based symbology, scale-based sizing, alternate symbols, display filters. Apply that to every layer in your map, and you're going to see some really impressive things happen with your vector tile generation. Okay. Quick breather. Let's get into raster tile generation.
Yes. This topic here is specifically for imagery use cases. When you're caching your imagery, what you should do.
So are raster tiles still relevant? Heck yes, they are. If you've got imagery, if you've got aerial photography, putting that into a vector tile is a no-no. You can do it. I've tried it. It's a little funky looking. Don't do it. Trust me. That's that little Lego that was buried in the shag carpeting that you stomped on in the middle of the night. Don't do it. All these maps that are presented here are the types of maps that we're going to want to create with raster tiles. Okay, another eye chart. Again, this is in the quick reference guide. Just for reference, you won't be tested on this. I apologize. So let's go over a few quick things just to talk about the different types of maps that we're going to be interacting with and the recommended tile size, or I'm sorry, tile type, and the types of things that we should be using to constrain and controlling the cache. So on the top left, we've got our nice hill-shaded topographic map. ArcGIS Pro is automatically going to detect the kind of map that you're making and make a best guess. But if you want to override that, this is the recommendation. If you want to go with JPEG, if you got a lot of color variation in your base map, JPEG 90 is going to do a couple of things. JPEG 90 means we're actually cranking up the quality to 90, 10% compression. We do that to avoid any artifacts around halos or anti-aliasing along roads. JPEG 90 actually fixes a lot of those artifacts that we see on the map. Likewise, in the lower left, is it my lower left or your lower left? My lower left, the navigation map. Again, a rather flat range of colors, but we're not showing the hillshade anymore. This will actually cook very well as a PNG. Now, this is not PNG 8, PNG 32. This is a smart tile type. PNG is going to analyze the color ranges in our current extent that are being cached, and it'll determine the most appropriate bit depth for that tile. And again, when I say custom AOIs, you're going to have to make some best guesses about where you need to generate cache, where is it important for your users to generate cache. Now, if we move over to the right side of the graph here with our image base maps, imagery is going to be served best as mixed or as JPEG 65. You don't have to use JPEG 75. You can actually get a little bit of, eke out a little bit of storage savings by dialing back the quality slightly. The nice thing about imagery, actually, who's using Mosaic datasets for their image collections right now? Anybody still using raster catalogs? Okay, we should talk about Mosaic datasets if you are. Please do. The nice thing about using Mosaic datasets is you get a very cool polygon that represents each raster dataset. Use those when it actually gets to caching. It actually help define at the largest scales using the highest resolution pixels. We don't want to spend a lot of time generating cache in regions that may only have 1 meter resolution, or caching beyond 1 to 4,000 where we only have, say, 1 meter nape imagery. Okay. Thirdly, in the lower right is the cool little terrain layer. So if you are creating your own custom elevation layers for ArcGIS Pro, the web scene layer, or ArcGIS Earth, right? We're going to create that in a web scene, and it's automatically going to use a tile type called LERC, which stands for Limited Error Raster Compression. Really fancy term that basically says instead of RGB values into the tile, we're actually going to encode elevation values. So this is actually how we can actually build that wireframe from the tile. We actually have elevation values cooked into the tile itself. And once again, use your Mosaic dataset footprints.
I want to intervene and tell you that if you're working with collector apps and you want to give them cache data for taking offline, and you want to reduce the size of the caches that you're working with, to see these are the configuration that you need to fiddle with. When he says JPEG 65 versus JPEG 90, JPEG 90 is going to take more space versus JPEG 65. And play around with these values and see which is the sweet spot for you, and then work around with it.
You want to talk about this?
Go ahead, if you're not tired.
Exhausted. All right. So when we're generating the cache on server, the mechanism for actually scaling your cache job, right? The idea of leveraging server to cache is because the ArcGIS server site is going to manage scaling this job across the multiple machines. But we need to give it an upper limit for how hard to beat the server about the head, neck, and shoulders. All right, so the way we control that is through the caching tools. Right? And generally the rule of thumb is if we have 8 cores on our machine, and we've got multiple machines in the site, in each of them they're all 8 cores, we want to set n, the min-max instances, to 8. Okay? Now play around with this. In some cases I've actually seen in very large implementations n-1 works better. Again, test. Repeat the process on a small area of interest, see what the utilization looks like. Now what do you keep an eye on when this is going on, when you're actually generating the cache? I'm sorry, I can show you the corresponding Linux thing out on the Expo floor, but for all of us fellow Windows kids, when you open up Task Manager on the server, it's not necessarily the CPU utilization that you're concerned about. You're looking at the commit ratio, that thing that's circled in yellow there. When that approaches 1, life for your server is getting more and more miserable. Right? You're basically consuming all available resources, physical RAM as well as virtual page file. Okay? You don't want to run out of RAM before you run out of CPUs. In other words, if you're finding that setting your instance to n is cranking up the number of CPUs to 100%, and you're also achieving a very near 1-to-1 ratio of in your commit ratio, chances are you're actually introducing some diminishing returns in terms of how fast you can generate the throughput, or how fast we're able to generate the tiles. So in some cases, it's actually beneficial to decrease n. So instead of 8, if we only have perhaps 16 gig of RAM, we can actually decrease this to 7 or 6 min-max instances. retest, see if the throughput, the actual time it takes to complete the cache job improves.
Make sure you never cache on your production server. If you're caching on raster tiles,
do it right, do it in production.
He's kidding.
I'm kidding, please don't.
I have heard many people, please do not. This is the reason why, okay?
Yes. Caching is not a gentle process. It'll do exactly what you tell it to do. If you give it all the resources that your machine has and you need to do other things with it, it's gonna be greedy and grab all the resources. So how do we actually, aside from scaling and leveraging ArcGIS Server, I've had the biggest gain just by being smart about how we generate tiles. Okay, so the cache job management. Aside from authoring our map and making that really fast and efficient, being smart about what we cache is equally as important. Okay, so for most folks, how many think you gotta cache this thing once? It's once and done. Okay, good. You actually should be doing multiple jobs, right? And you can actually tailor the area of interest at these ranges of scales. And we're gonna show you how to actually do this here in just a minute. Right, so break your cache project up into multiple jobs, ranges of scales. At the small scales, you want the broadest coverage, but at the largest scales, you want the actual pockets that are most interesting, wherever your data is most compelling, or wherever is most, I don't know, appropriate for the type of use cases of your base map. The other interesting thing here is, once you generate all the base map cache, if you do make updates to your map, you don't have to recook the whole thing. If you're, again, I go back to the parcel data as an example. Just because you have statewide parcels, we don't need to regenerate all the parcels every week. We can actually just pick and choose the extents and parcels that have been updated, labels have changed, geometries have been updated, and just update those regions of cache. And that job will go much faster than the original population of the cache. So again, when we talk about server scalability, one of the nice things is that I've been blessed with is I've gotten to work on several projects, very, very large projects where I've got, like I said, a caching problem that I have to provide global base maps on a quarterly basis, times 16 products. So one of the things that we invested heavily in was a large server processing environment. Now, again, to overwhelm you further with large complex graphs, millions of tiles per minute. This is the metric that I try to capture. That's really the sort of the real crux of the matter, because just bundles per second, gigabytes of cache. The thing that's going to be most telling of how fast you're generating cache is tiles per minute. Okay, so what this is saying that with an 18 server site, 18 machine site, I'm able to generate approximately 1.6 million tiles per minute. All right, the thing works. Not multiple cache, not multiple Python jobs trying to figure out how to scale and distribute the jobs. Give server the work and let it scale the job across your site. Now, how many of you are going to have 18 machines to play with? I'm not doing this to brag. I'm just saying, look at the left end of that spectrum. If you want to talk return on investment, you want to make a pitch to your boss for investing in 1 or 2 extra machines, you're going to get through your job twice as fast by adding a second machine. Okay, add a third machine to it. Look at the better than linear growth that we're seeing in terms of tile throughput. Likewise, the completion time went from 6 hours at one machine to 20 minutes with 18 machines. These were all bare metal machines. They were originally VM hosts that I bastardized and turned into Windows machines and just said, you're massive, you got 32 cores and 256 gigs of RAM. Perfect. You're now gonna be my little caching rig. Little, but yes. So again, when we kind of wrap up the tile generation, optimize your data, get the data local to the servers, optimize your MXD in your Pro project by following best practices for the vector tile generation. Configure your ArcGIS server caching instances. Give your server a little bit more room to wiggle in terms of how to tap and scale the number of instances that can run across that site. Optimize your cache jobs. Again, this is generally where I saw the biggest improvement in terms of being smarter about how I generate the cache. And remember, the dog is going to hunt. ArcGIS server will scale with 1 machine, 2 machines, or 18 machines. It just works.
So let's just dive into a very quick one because we don't have much time. We'll quickly
About 10
delve
minutes.
into.
We can talk about a lot in 10 minutes.
We really want to get to your questions. So let's just quickly breeze through on how you publish these things from ArcGIS Pro. If you want to publish a map image layer from Pro, the workflow would be to go to the top hand corner and use web layer.
The share as web layer.
Publish web layer, and you have the option to use reference or copy all the data. We always recommend you to reference the data when you are publishing a map image layer.
Again, because we've copied that file geodatabase to each one of our server machines, we don't want to reference an enterprise geodatabase. It's basically a single point of failure, bottleneck, where all of our data, all of our machines are going to be scrambling to get a connection to. So again, reference registered data. The next thing is we want to click on this menu here, Map Image Layer, and this is where it's going to look somewhat familiar if you've generated cache before. Now the key piece here is we want to cache manually on the server. Why? Because we want to make sure that we can do this sort of functionality where we can pick the jobs that we want to do. If you don't cache manually, it's automatically going to generate cache for the full extent of your map, and it's going to go until it's done, which is not a terrific thing, but when you've got a large cache project, cache manually on the server, manage your cache jobs later. And so again, we actually manage those cache jobs with the Manage Map Server Cache Tiles tool. Once our service is published, the cache structure is on disk, but it's empty. We haven't created any tiles. We use the Manage Map Server Cache Tiles to pick the scales that we want, the corresponding area of interest that we want, and then we hit go. Grab a Snickers. When that's done, lather, rinse, repeat. All right. For image services, it's a little bit different. Instead of initiating it from the share as a web layer, instead we want to initiate this from a mosaic data set or a raster data set and share as an image layer. Again, we're going to configure the tile layer, establish our tiling scheme, pick our scales, cache manually on the server. Same exact process after that, use Managed Map Server Cache Tiles. For the terrain layer, again, a little bit different. We start with a web scene this time. We add our terrain layer to that, share as web scene. We click on the WEL, which stands for Web Elevation Layer. We configure that, pummel through some nested pop-ups here, and actually get to the cache configuration for the Web Elevation Layer. Cache manually on the server. It's automatically going to populate that drop-down with a 0.1 for the lurk compression. Who here is using 1 meter or better elevation data as a terrain surface? Okay, we should talk, because you may need to tweak this value to a much smaller level. Generally, the indicator will be if you see stair steps in your resultant image, then you need to go with a, I forget what it is, 0.05 I think is going to be a more appropriate compression level for you. Okay, now we've been talking about publishing, caching with our base maps. With vector tiles, it's a little bit different. We actually cache, then share. Again, because we're generating the vector tile package on our workstation instead of server, we're actually going to do all the authoring, the caching, and then we give it up to our organization.
So the Pro is generating caches for you, and then you're uploading the caches to your enterprise server.
Good point. So again, we initiate the vector tile caching workflow from the share as a web layer, and we can go into, our tiling scheme is going to be interpreted from our map frame. So again, if you want to use a custom tiling scheme, we have to set our map frame to a custom tiling scheme. We don't have to reproject our data. The reprojection of the data is on the fly at the time of encoding. But instead of using the auto-suggest, you would actually specify a custom tiling scheme, and that's where you can actually tailor to the coordinate system that you're using. Now this is going to be a once and done sort of a workflow. This is going to analyze your map, build the index in memory, generate the vector tile package, upload it to your organization. Again, because you're signed into Portal, whenever you initiate this tool, it's going to upload that vector tile package to that Portal instance or to ArcGIS Online, and then it's going to deploy the tiles. It's actually going to hit that publish button for you behind the scenes. So at the end of this whole process, you've gone from a map to actual vector tile layer that is deployed to ArcGIS Online or ArcGIS Enterprise.
So let's talk about updates. Tommy was talking about when you're updating a cache map service, you have to make sure that areas where the updates have happened in your files database or enterprise database, and then how you can update using AOIs. With vector tiles, you cannot update for partial extents. The only way is to create the cache for the entire map service.
We've been getting this question a lot this week. Is it better to, when are vector tiles going to support delta updates? Well, I don't know. It's tough because when you can cache the entirety of North America, US, Canada, Mexico, Alaska, Guam, Puerto Rico, in 45 minutes.
For the entire ArcGIS online tile.
Again, from scratch in a street map style map. If you can do that in 45 minutes, is it really worth agonizing over trying to figure out delta cache? So to this end, we're actually recommending when it's time for an update, you actually have to generate the entire project over again. Again, the state of Rhode Island takes 2 minutes to cache. All of California takes about 5 minutes to cache.
So you can script this workflows using the GP tools which are being used for these UI experiences. The GP tools here are the Create Vector Tile package tool and the Share package tool. Run them in a script mode whenever you want, and then upload this tile layer into your ArcGIS Enterprise. Let's say you've got release candidate 2, and then you want to update it.
Right. So we've actually prepared a new vector tile project. We're going to call this version 2. We run it through the same process. It actually is going to have now 2 hosted tile layers in our organization account. We've got the one that everybody's currently using, and now we've got this one behind the scenes that's not shared. But
you go to your production layer and then hit Replace Layer. Choose the newly published layer this is the release candidate 1. And then you can choose to update the item information, which is the thumbnail, in case it has changed. Most of the time, it stays the same, and you say Replace. You can script this using the Python API too. We have given you the URL to this so that you can update the whole process using scripts and have a daily update or monthly update process for your vector tiles.
So the massive appeal for Replace Layer is it's no longer destructive. In the past, you had to destroy the hosted tile layer and republish that. The REST URL stayed the same, but the portal item was different. So if you had any maps, web apps, or anything that was actually leveraging the portal item, well, that developer's got to go back to work, right? In this case, we're actually maintaining the same REST endpoint. The item ID stays intact, and it's instantaneous. Because these 2 things are already on disk, we're just doing a swap behind the scenes of the actual cache directory, right? We maintain the old one in case we introduced a regression with our map, perhaps an unsupported layer, or something broke the style. We can actually roll back to the archived layer. So you can very quickly maintain and update these things. All right, so choose wisely. Whether vector tiles or raster tiles, the options are plenty, but keep these things in mind. How did I not change that? It's a small footprint, 26 gigabytes. I'm lying. It's 40 gigabytes for the world now, for the vector tile base map. Right? Raster tiles, you can have terabytes of cache.
So basically, use vector tiles. If you have a vector content, use vector tiles. If you have raster contents, you have to use raster tiles. But if you're going to the vector tiles route, be aware vector tiles cannot be consumed by ArcGIS ArcMap and older clients. And vector tiles do not support pop-up info, query, or identify as your cached map services used to. So for pop-up, identify, and query operations, you have to have a feature layer on top, turn off the visibility, and then it will be able to support the query on it.
So also in the read ahead, I've given you this really hard to read slide. Again, not for the presentation purposes, but it's got all these helpful URLs and links, as well as another plug for the cartography MOOC coming up in April, as well as some very helpful other links in there. So enjoy that. I'm going to put that slide back up with the URL to the read ahead slide here at the end. Again, some other sessions that are coming up, but last and certainly not least, please fill out the survey, give us a like, thumbs up, mash that like button, and subscribe. And yeah, let's do it. So who had a good time? All right? Right? Excellent, good. I did too.
Thank you.